Bismillahirrahmanirrahim. In the name of Allah, the most merciful and the most beneficent. So today we will discuss about algorithms and different programming concepts. What are the basic concepts of programming and how these concepts are useful. So first we will have a look to the some basic terminology so we can understand the remaining lecture more effectively. So what is an algorithm? Algorithm is a series of steps that perform to solve a specific problem. So an algorithm specifies a procedure for solving a problem in a finite number of steps. After that, we have a term correctness. Correctness means how easily its logic can be argued to meet the problem's primary goal. So I just really try to explain all these things in or write all these terms in very simple way, so if we just read it so we can understand it very well. So in correctness we just have to make it very easy all the logical steps so we can easily grab our goal what we want to perform with the help of that algorithm. So data is a symbolic representation of value. Debug is in actual a problem or to search a error and to remove a error, remove that error from the program. High level, we have high level programming languages, low level programming languages. We already discussed these in detail in our previous lectures. However, high level languages are similar to human languages that make it easy for programmer to write a program and to solve a problem. However, in low-level languages, programming languages, those languages are more closer to the native languages of the computer, that is binary language that has codes 1 and 0. In the investigation step, it is a step to determine the input, output, and processing requirement of a problem. So in investigating step, we have to explain all the processing steps, what will be the outcomes and what will be the input. All these will be discussed in investigation step. Then we have machine languages. Machine language is a language that provides instructions in the form of binary numbers, and binary numbers, as you know, 1 and 0. And computer will directly respond to that binary numbers. So that are known as machine languages. After that, we have probability of languages. A programming language that is not a machine dependent language and can be used by any computer is known as probability language. What is a program? Program is a logical set of different steps that can specifically perform a specific function or to solve a specific problem. That is a program. Programming language is composed of a set. Programming languages are languages that is composed of a set of instructions that can easily understand by a programmer. For what is programming? Writing a program is known as programming. And what is the termination? Termination means to stop a program, to finish a program, or close of any procedure is known as termination. Top-down analysis, it means breaking up a problem solution into smaller modules and define their interconnections to provide the total solution to a problem. If you can break a problem into smaller pieces and then solve each piece to solve that specific problem, that is known as top-down analysis. After that, we have variable. Variable is a container or storage location for storing a value that may or may not vary during the execution of that specific program. So now we will try to explain all these. So algorithm, as we already discussed, that algorithms are the series of steps that perform to solve a specific function. The procedure has to be based on definite reasoning and specific logic that just have a conclusive result. A well-designed algorithm will always provide an answer. If you don't have any answer, if your algorithm is not providing any logical or conclusive answer, it means that there is a problem in the algorithm. So if your algorithm is right, you will get the answer. What is an algorithm? Computer scientist Nicholas Wirth stated that program is equal to an algorithm and data. An algorithm is a part of the plan for a computer program. An algorithm is an effective procedure to solve the problem in a finite number of steps. These are the different explanations that I already explained you, that algorithm is a series of steps to solve a specific problem. It is an effective means that an answer is found and it has a finite number of steps. So there are different ways to stating algorithms. Algorithms may be represented in various ways. However, there are four most common ways to represent an algorithm. That is flowchart, pseudocode, step form, and Nasse-Schneiderman. So we will study all these one by one. Schneiderman, Nasse-Schneiderman, flowchart, pseudocode, and step form. So what are the key features of an algorithm and a step form? Here is an example of algorithm for making a tea. If you want to make a tea, first of all, you have to take a kettle, then just put the kettle on a burner, then switch on the burner, add the water, and when the water will start boiling, you have to add the specific ingredients, and then you can have that tea. So this is the specific example of a making of tea. That is a problem. So if we just read it, if the number one, if the kettle does not contain water, then fill the kettle. Number two, plug the kettle into the power point and switch it on. If the teapot is not empty, then empty the teapot. Place tea leaves in the teapot. Switch off the kettle. Pour water from the kettle into the teapot. From this example, it is evident that the algorithm shows these three features. First one was sequence, then decision, and then repetition. That is in our computer language or in our programming language, sequence is known as the process, decision is known as the selection, and repetition is known as the iteration or looping of a specific function. So if you are just going to analyze the sequence or what is the process to make a tea, or if you are going to design an algorithm for making a tea, the first step will be the sequence, and sequence means that each step or process in the algorithm is executed in a specified order. You cannot add tea leaves before the water, or you cannot add the tea leaves on the burner. So you have to move specifically sequentially. First, you have to switch on the burner, then you have to put the kettle on the burner. So you have to follow this sequentially. So that's the main key if you want to design an algorithm. In the above example, each process must be in the popular place, otherwise the algorithm will fail. The decision makes, after that we have decision, that is known as selection. In decision we have some ways, like if you want to add the milk, if you want to add the specific type of tea leaves, what you want to add, that will be your decision for making the tea in the above example. So decision constructs if then else. So these are the preposition, or you can say these are the conditions. If there will be no water, then you have to add the water. If there is no water available, then you can add the water, or else you can skip that process. So these are the conditions you can say. So if there is a preposition, then process one, and else otherwise you have to follow the second process. So this is the decision making. This means that if the preposition is true, then execute the process one, else or otherwise you have to execute the process two. And after that we have repetition, that is known as construct, looping, or iteration. First one, we have to sequentially follow the steps. Second one, we have to make a decision. We have to give some conditions. If the first process will not complete, we should have the alternative process. After that we have repetition. Repetition constructs, repeat, and while. Repetition can be implemented using constructs like the repeat loop, while loop, and if then go to loop. So we have three different types of loops. I hope you studied loops in your other courses of computer sciences related to computer sciences. In loop, we have for loop, while loop, go to loop, and then we have if then go to loop. So different loops are available. So the repeat loop is used to iterate. In repeat loop, we have to repeat the specific sequence again and again, until we have our specified result. So that is known as repeat and repetition. Process one, like here, process one, process two, and process n, until the preposition. We have to perform this process again and again. After that, we have correctness, and the prepared algorithm needs to be verified for its correctness. As we already discussed in the first page, that correctness is the logical or easiness of making a specific algorithm easy and conclusion will be accurate. So the prepared algorithm needs to be verified for its correctness, that is it correct, is it giving the correct result, is it moving easily. So correctness means how easily its logic can be argued to satisfy the algorithm's primary goal. Correctness is the degree to which an algorithm performs its specified function. The most common measure of correctness is defects per kilo lines of code, KLOC, that implements the algorithm, where defects is defined as the verified lack of conformance to requirements. So this requires the algorithm to be made in such a way that all the elements in it are traceable to the requirements. So the algorithm should be so clear, so easy that every step should perform a specific function and solve the problem. After that, we have variables and data types. The data used in algorithms can be of different types. Like, there are different types of data. The data of age, the data will be in number, data can be in numbers, data can be in characters. If your name is in as a data, then it is in character. If your age is data, then it's a number. If your marks is data, then it's a number. So these are the types of data. The simplest type of data that an algorithm might use are numeric data, like 1 2 3 4 5 6 7 8 9 10. After that, alphabetic data, A B C D. This is alphabetic data. Then we have logical data, that is prepositions with true, false, the statement is true or not. Then we have conditions. So these are the variables and different data types. Then we have naming of variables. Every specific variable should have a specific name, so we can call it easily. So one should always try to choose meaningful names for variables in algorithms to improve the readability of the algorithm or program. So you have to write the specific easy name to the variable so you can understand, and if another programmer is going to read your code or your algorithm, and then he or she can easily understand that what you want to explain in that variable. This is particularly important in large and complex programs. So data is a symbolic representation of value. A variable which has a name is a container for a value that may vary during the execution of a program. So here we have an example. We have algorithm in plain English, then we have algorithm in variable means. So in plain English, we just take an example of kettle. So in simple words, first one, kettle does not contain water, then fill the kettle. Plug the kettle into the power point and switch it on. If the teapot is not empty, then empty the teapot. At the fourth position, place the leaves in the teapot. And fifth one, if the water in the kettle is not boiling, then go to step 5, and we have to boil the water again and again. Then at point 6, we have to switch off the kettle, and then at point 7, we have to take the tea out. However, in algorithmic language, or you can say algorithm using variable names, in first one we can use if kettle empty, then fill the kettle. So we are just putting a condition here. We are going to take a decision that if there will be no water, then we have to fill the kettle with the water. At the second step, plug the kettle into the power point and switch it on. Third one, if teapot not empty, then empty the teapot. Again, we are giving a condition here. For the fourth position, place tea leaves in the teapot. And then we have fifth one, if water not boiling, then go to step 5. It's again a condition, then switch off the kettle, and then we have to take the tea out. So there is small differences. However, sometimes we have to give some conditions for specifically performing the experiment or solving our query. Then we have subroutines. A subroutine is a logical collection of instructions that is invoked from within a larger program to perform a specific task. The subroutine is relatively independent of the remaining statements of the program that invokes it. A subroutine can be invoked several times from several places during a single execution of the invoking program. So you can understand it that in subroutine, you have a specific collection of logical instructions that you can add anytime in a large program. So you just have to take a call, and then you can call that specific patch of instructions to that specific point. So that is in actual a routine. Like you can say that you have already prepared some steps of a specific problem and you don't need to write it again. You just have to take a call and then use that. So here we have the program structure. After completing the specific task, a subroutine turns to the point of invocation in the larger program. So here we have a example of program structure. Here we can understand subroutine also very easily. Suppose we start a program, then we have four or a specific number of instructions, and then we perform a structure of for a simple program. This is a simple program structure. You have some steps or you have some instructions. You just follow it and solve a problem. After that, here we have in the B, we have some conditions. Like we start the program, then we have a statement 1, then we have a procedure X, statement 2, procedure X, and every time we have a statement and we have a specific procedure, and then we just solve the problem. So in this structure, it is a structure of a program with repetitive procedures. In the first one, we just have a simple structure of a program. In this one, we have different procedures also. However, the third one we just call the subroutine. As I already explained, that subroutine, you can say instructions are already there. You just have to take a call and just use it. Here we start the program, statement 1, then we call that specific subroutine of procedure X and then use it here. Similarly with statement 2, 3, and 4. This is a structure of a program using a subroutine. In the first one, it is a simple program. Second one, there is repetition of procedures. In third one, we are using a subroutine that is placed somewhere else. We just take a call and use it. Then we have example of developing a specific algorithm by using step forms. For illustrating the step form, the following conventions are assumed. Each algorithm should be logical. Then there will be a starting point of that algorithm, and then there will be a closing point of that algorithm. After that, to accept the data from the user, there should be an input or a read statement that we have to use for developing a specific algorithm. To display any user message or the content in a variable, print statement will be used that will be helpful for the user to study that specific points. Note that the message will be enclosed within the quotes, so the reader can easily understand what is in actual the message and what is the coding. There are several steps in an algorithm. Each step should have a specific action or a result. So the steps are to be acted upon sequentially in the order they are arranged or directed. The arithmetic operators that will be used in the expressions are, we have to use different types of arithmetic expressions to explain what we just want to say to the computer, because we cannot talk with computer. We just have to give instruction to the computer. So here we have this arrow. This means alignment, assignment. The left hand side of the should always be single variable. After that, for the plus sign, for the addition, we use plus sign. Subtraction, we have this sign. For multiplication, we have static sign, and for division, we have a slash sign. So these are the expressions we can use for specific function, or we just for specific instruction we can give through the algorithm. So in preposition, you can very well that what is the sign of greater than, less than, or equal to, greater than or equal to, and not equal to. So this is very easy. You can about that. So after that, we have some gates that is known as and, or, not, three different types operators. So in and we have conjunction. Conjunction mean joining of two things. That is the if you want to join two things, like if you want to say I need first glass and the second glass of water, then you can use add. That is conjunction, joining 2 points. Then you have disjunction, in which you just take one, that you will use or operator there. And for negation, if you want to negate something, you will use not operator there. So after that, we are just jump on pseudocode. Pseudo mean that is not much accurate, or not much virtual physical. So like stepwise pseudocode is a written statement of algorithm using a restricted and well-defined vocabulary. It is similar to 3GL, that is languages. We already studied that there is different types of languages in our previous lectures. That is 1GL, 2GL, 3GL, 4 and 5. So here we have 3GL. And for many programmers and program designers, it is the preferred way to state algorithms and program specifications. Although there is no standard for pseudocode, it is generally quite easy to read and use. For instance, a small pseudocode is written as follows. So we are going to just read that small code, pseudocode, so we can understand. So do while cattle empty, it's a very small code we have here. Like do while cattle empty. If cattle is empty, we have to fill it, add water to cattle, and do while. And do while. So this code just start with the step with cattle, and if the cattle is empty, we have to add water to the cattle, then boil the water, put the leaves and pour the water into it, and then end it. So this is the basic steps we are that are used to solve that problem of cattle. After that, after pseudocode, we have flowchart. We already studied that there are different steps like pseudocode, flowchart, and others. So after pseudocode, we have flowchart. A flow, you guys know very well about flowchart. These are specific diagrams that just have a flow of information, and if you just follow the arrows or steps, you will get the result. So this is the flowchart. A flowchart depicts appropriate steps to be followed in order to arrive at a solution of a problem. It is a program design tool which is used before writing the actual program. You have to generate a flowchart before generating your actual program or algorithm. So when you have a good flowchart, you can easily generate the program. So guidelines for drawing a flowchart, it is very easy. You will learn it very quickly, I hope so. Flowcharts are usually drawn using standard symbols. There are some symbols that we use to generate a specific flowchart. We are going to discuss all those symbols. Some special symbols can also be developed where you just need that. So if there is this type of oval shape, so this means the program is going to start or going to end. When you have this rectangular box, it means there's computational steps or processing function of a program. Then we have this tilde one. This means input entry or output display operation. Then we have this diamond type four sided face. That is a decision making that just give a specific decision. If you have any decision, then you have to use this one. Connections remote, and this one is magnet tape. This one is magnetic tape. This one is magnetic disk, and this one are flow lines, that is where the arrowhead will be. It means you have to going to move that way. And this one is like add comments or furnish clarification, and this one is for display. So these are some common symbols. If you just memorize it, you can generate a good flowchart. So like here we have an example, like for this one, as we already studied, that if the box is like this one, there will be input or output. For this rectangular, there will be processing. This one is for termination or for start. This one is for sub program. This one is for diamond, is for decision making. So here we have some examples. Like this one is sequentially, that arrow will guide us that we have to move upward to downward. So this is a simple sequential flowchart. However, this one is binary selection, that first you have to add here. This one, you know, a diamond is for decision making. So if you have to follow this one or you have to follow this one. For rectangular, we have a process and then we have a result. So this one is binary selection. Multi-way selection, you have more than 3. This one, in multi-way selection, you have more than 2. It is for decision and this is for processing. This is multiple. This is binary. There is only 2 options. This one sequential, you don't have any option. You have only one option and you have to follow that. That is in sequence. In binary, you have 2 options. In multiple, you have more than 2 options, that which step you are going to perform or which side you are going to move. Then we have this example of repetition pre-test and repetition post-test. In repetition pre-test, we have to check it again and again before the test, and in post-test, we have to repeat the steps after the test. So these are the standards. These were some standards symbols, and then we have standards for flowchart. The following standards should be followed to generate a good flowchart. I am just going to read it because it's very easy, and you just have to memorize it for your learning, and you have to generate the flowcharts. Flowchart must be drawn on white paper on one side only. Flowchart start on the top of the page and flow down and to the right. So you have your page should be wide and you have to start from the upside to downside, from right to the down, move to the right of the downside. Only standard flow charting symbols should be used. You cannot use any symbol that is not known to others. Only standard flowchart symbols you have to use. A template to draw the final version of flowchart should be used. The content of each symbol should be printed legally. English should be used in flowcharts, not programming language. You just can use English language to design any flowchart. The flowchart for each subroutine, if any, must appear on the separate page. If you are going to add some subroutines, then you have to generate that the flowchart of that specific subroutine separately on any other page, not on the same page where you are going to generate your original or the original flowchart. Draw arrows between the symbols so you can understand that from which steps you are going to the other step. What are the advantages of using the flowchart? You can easily communicate with the help of flowchart. If your flowchart is designed accurately, you don't need to explain it again and again. The reader will just understand what is happening in the flowchart. Flowchart is very effective for different type of analysis and to solve different problems. Flowchart can help you to generate a good program. Flowchart can help you to design an efficient coding. Flowchart can help you to remove the debugs and errors. Flowchart can help you to generate efficient programming maintenance. So what are the limitations of flowchart? So every step has positive and negative and positive points. So we already discussed the positive points or benefits of flowchart. So however, there are some limitations of flowchart that has complex logic. Sometimes the program logic is quite complicated. So in that case, you cannot explain everything in the flowchart. Sometimes you have to alter or modify the flowchart. You have to redraw the flowchart from the first step. Suppose if you want to add some process, you have to generate all the flowchart again. So reproduction, since the flowchart symbols cannot be typed in, the reproduction of a flowchart becomes a problem. Sometimes when you are going to design your flowchart, sometimes the programmer just lose the objective what they are going to achieve. So these are the limitations of the flowchart. After that, we have strategy for designing a specific algorithm. That is very important. If you just try to understand the specific strategy and you just follow the strategy, you can design a very good algorithms, and good algorithms always works. So as we already studied about investigation step, here we have the detail of investigation step. That first we have to identify the outputs needed, what we want to achieve, what we want to gain in actual. Second step is identify the input variables available, what we have that we use to achieve our goals. Third one is identify the major decisions and conditions, what conditions we can apply and how these conditions will be helpful for our analysis. Fourth one is identify the processes required to transform inputs into required outputs. And the last one is identify the environment available, that what resources you have in actual. Top-down development steps. Devise the overall problem solution by identifying the major components of the system. Verify the feasibility of breaking up the overall problem solution. So when you just break down these problems, break down the problems into different steps, we can easily overcome that problem and we can have a good conclusion. Stepwise refinement. Work out each and every detail for each small piece of manageable solution procedure. So you have to take every step very carefully. You have to work very hard to solve the problem. Decompose any solution procedure into the further smaller pieces. If you can decompose the small pieces into very small pieces, you have to do it just to understand the problem and to solve the problem. So group processes together which have some common points. You have to gather the common points and use that common points. Group variables together which have some appropriate common points, same points. Test each small procedure for its detail and correctness and its interface with other small processes, so you can easily overcome the problem. So these 5 steps you have to follow to break the problem and to understand the problem, so you can easily design a very good algorithm. Tracing an algorithm to depict logic. How your algorithm will explain a logic, how your algorithm will be helpful for logical conclusion. An algorithm is a collection of some procedural steps that have some precedence relationship between them. Certain procedures may have to be performed before some others are performed. Hence, an algorithm is a collection of procedures that results in providing a solution to a problem. So these are the common practices we already discussed to solve that, to just design a good algorithm that can depict a logic. And there should be a logic in the algorithm. If your algorithm don't have any logic, then there is no need of that algorithm. After that, we have to convert that algorithm into a program. That is more important also. So you should know that how you can convert your algorithm into a program, and then you have to run that program to solve the problem. Once the algorithm for the solution of a problem is formed and represented using any of the tools like step forms or flowchart or pseudocode, it has to be transformed into some programming languages. And you know about, we already discussed many programming languages. The general procedure to convert algorithms into a program is given as follows: code the algorithm into a program, desk check the program, evaluate and modify if necessary the program. Do not reinvent the wheel. To convert an algorithm into a program, first of all, we need a programming language, and we just have to write a code. After that, we have to check if there is any problem, we have to solve it. After that, we have to evaluate, is it working accurately? If not, then we have to change something. And do not reinvent the wheel. If there is always softwares are available, programs are available for that specific problem, then you don't need to again write the program for that specific problem that is already have solutions. So here we have some pseudocode languages. Pseudocode language, this is the pseudocode language and this is the C language code. So loop, we have while, exit loop, we have break. So this is the example. If you are just writing a pseudocode, then you can use these symbols. However, when you are going to code the program or algorithm, then you have to use these one in C language. This is the pseudocode of C language in actual. So the process of programming, what is the process of programming? There are some logical and sequential job steps which the programmer has to follow to make the program operational. If you want that your algorithm and your program should be accurate, then you have to follow these 5 steps. That first one, understand the problem to be solved. First of all, you have to understand the problem. You have to break the problem, understand the problem, analyze the problem. Then you have to think and design different solutions, all the possible logical solutions to solve that problem. Then you have to write the program in the chosen programming language that you are in which you are expert. After that, you have to translate that program into a machine code, and then you have to test the program that is it working or not. You should have some sample data, and you have to use that data. After that, in the last step, you have to put that program as an operational program. So it is very easy. You have to just try to read it and understand it. I just try to explain it in very easy words for you. So after that, you have an activity. You have to prepare a flow chart. This one. You have to prepare a flow chart to read the marks of a student and classify them into different grades. If the marks secure and are scored are greater than or equal to 90, the student is awarded grade A. And if the marks are equal to or greater than 80, then it's less than 90, then grade B. And if the marks are greater than or equal to 65 to 80%, then is C. And the last one is the D. So you have to generate a flow chart with the help of that symbols we already discussed, that has different processing and different decision steps. So you have to generate this flow chart and discuss with me. Thank you so much.